Hi. In the previous lecture, we talked about kind of a fun model where students could be alert or bored. Remember, it was a Markov model, and these Markov models, there's a set of states, in that case, alert or bored, and then there's these transition probabilities that give you the probability of moving from alert to bored. Well, I want to move in this lecture to a slightly more complicated model, and it's going to be a model that involves countries, and these countries can either be free, partly free, or not at all free, being run by dictators. And I want to look at the dynamics of that situation. It'll help us sort of maybe learn a little bit more about how these Markov processes work, see how we can extend them to more dimensions, and also come up with a somewhat counterintuitive finding. Okay, so let's start simply with even just a two-state democracy model. So I'm going to imagine there's two types of countries. There's democracies and there's non-democracies. And I'm going to assume that 5% of democracies switch into dictatorships every decade, and that 20% of dictatorships become democracies. So that'll be my assumption, and then let's just walk through the logic. So how do we do this? Well, we're going to write down a Markov transition matrix. So let's start out by assuming we have 30% of countries that are democracies and 70% are dictatorships. So of this 30% that are democracies, we know that 95% will stay democracies. Of the 70% that are dictatorships, we know that only 20% will become democracies. So to figure out how many will be democracies next time, we just take this row and multiply it by this column. So we get 0.95 times 0.3 plus 0.2, right, times 0.7. So maybe I should parentheses around here. So this is going to be 0.285, and this is going to be 0.14, and that gives us 0.425. So we're going to get 43% of countries in the next decade are going to be democracies. And we could do this one more time and say, well, if we have 43% or 42.5% democracies, we multiply this row by the column, we're going to get that 52% of democracies next time. Now, if you looked at this trend, you say we start out with 30% democracies, then we go to 42%, then we go from 42% to 52%. Well, you might just sort of extrapolate, look, that looks like a linear trend, and eventually we're going to end up with everybody being a democracy. But yet we know that that's not true, right? We know we can solve for the equilibrium, and that it's probably going to involve some churn. So how do we solve for the equilibrium? Remember from last time, right? We just want to take this row times this column, where now instead of putting down a specific probability, we put p and 1 minus p. We want, after we multiply that through, that we get the same p back. So that means it's going to be 0.95 times p plus 0.2 times 1 minus p should equal p. All right, we got a bunch of stuff. Let's just multiply this by 100 to get rid of everything. So we get 95p plus 20 minus 20p equals 100p. Right, I just multiplied both sides by 100. Now if I bring everything over there, I'm going to get 20 equals 25p. So that means p equals 4/5. So here's sort of the surprising thing. We only end up with 80% democracies. Even though, right, 95% of democracies stay democracies and 20% of dictatorships become democracies in each decade, we still end up with only 80% democracies. That's what's counterintuitive. And that's why having this Markov model can be really useful, because it helps us really figure out what's going to happen, as opposed to just maybe extrapolating and thinking, boy, there's this big trend towards democratization. If things continue as they are, everything's going to be a democracy. Well, now let's move to a more sophisticated model. Now let's suppose that we classify countries not as just democracies or dictatorships, but we have three categories: free, partly free, and not free. And this is some data actually from Freedom House that I just plugged into Excel and plotted out. And what we see is an increase in free countries and a decrease in not free countries and a slight decrease in partly free countries. And we could ask, what's likely to happen? Well, what you can do, if I plug in sort of in 5-year increments the transition probabilities and do some crude estimates, sort of get the following. I get that each decade 5% of free and about 15% of not free become partly free. So those are those transition probabilities. And 5% of not free and 10% of partly free become free. And 10% of partly free become not free. So all sorts of transition probabilities here, kind of complicated. The matrix is more useful. So I can put free, partly free, and not free right here. And then I can put free, partly free, and not free here. And now I've just got 3 states. So it looks just like I had before, except for instead of a 2 by 2 matrix, I've got a 3 by 3 matrix. Same thing goes. Now, it used to be, before we had computers, when you went to 3 by 3 and 4 by 4 matrices, you just go, oh no, it's going to be a lot of math, a lot of algebra, and it was. But now that you've got computers, it's very easy to just make a huge matrix and solve for the equilibrium. There's nothing complicated about it. So what does that equilibrium look like? Well, all we do is take each one of these rows and multiply it by the columns, but now the column has a P, a Q, and a 1 minus P minus Q, instead of just a P and a 1 minus P. And I want it to be the case that when I multiply this row times this column, I get P, and when I multiply this row by the column, I get Q, and when I multiply this row by this column, I get 1 minus P minus Q. So a lot of algebra here, you can do it, and if you do it, you get the following answer. You get that 62.5% of countries will be free, 25% will be partly free, and 12.5% will be not free. Now, if you looked at that initial graph, you might have thought, oh, look, there's this trend towards freedom. We're all going to be free. But in fact, if transition probabilities stay fixed, well, fewer than 2/3 of countries will be free. So again, that's sort of surprising, because if you look at this trend, you think, my gosh, we've gone from 25% up to 45%. It looks like very soon we'll all be free. But in fact, assuming those transition probabilities stay the same, you end up with about 62.5% being free. Here's what our model shows. Our model's not quite as good. Our model sort of shows these general trends like this. If I plugged in that same initial condition and ran my model, I get this sort of picture. It doesn't look exactly the same as that picture, but it doesn't look bad. Another way to look at it is to say, if I feed those probabilities in and start it in the initial case, how close does it get? And what you can see is the model comes up at the end of the 40-year period with values that are really close to what we saw in the real world. Now, the reason they're so close is because I estimated my transition probabilities from the actual data. So it's likely to be really close like this. But what's more interesting is that the patterns look fairly similar as well. Now, does that mean we can buy into the 62.5% for sure? Probably not. It doesn't mean it's going to be exactly right, but it does mean unless those transition probabilities change in a very serious way, we're not going to get to 100% free countries. We may be more likely to see something like 2/3. So what have we done? All we've done in this lecture is shown that we started out with that simple alert board model. That was a toy model. We often do that when constructing models. We take something very simple, it's kind of fun, we can all understand it, and see how the process works. Once we understand the model, then we can take it to real problems with more dimensions and even tie it into real data and get a deeper understanding of how the model works. And in some cases, get fairly surprising solutions. Right? So here, the surprising result was that even though there's a trend towards more free countries, if transition probabilities stay in the range we're in, we shouldn't expect to see everyone be free. We should expect to see only 2/3 of countries be free. Okay, let's move on now, though, and talk about why that converges at 62.5%. What's causing these Markov models to go to equilibrium? And we're going to learn something called the Markov convergence theorem. Okay, thanks.